So you see, if you solve this second order differential equation, m d square x by dt square plus kx is equal to 0, you get the solution for the displacement function x, and this is in the simplest form. This is c sin pt, where p and c are important findings. P is a term which gives us the periodicity of this function. The periodicity is called 2 pi by p is periodicity of function. Remember, p is defined, p we have taken in such a manner that p is equal to root over k by m. So we know p, therefore we know periodicity of this function. In case of motion, this periodicity is nothing but time period, because periodicity by its very definition is an interval after which the displacement function repeats itself, and that is, in case of physical motion, that is nothing but the time period. So time period is equal to 2 pi by p, and if we put the value of p, we get 2 pi root over m by k. So t is equal to root over m by k into 2 pi. So immediately, the moment you get a simple harmonic motion situation where f is proportional to x or f is equal to minus kx, you can immediately find out the time period, because the time period will be root over m by k. What is k? Well, don't confuse it to be spring constant, because in the case of a block and spring motion, k is the spring constant. K otherwise is called the force constant. What is the force constant? It is simply the ratio of the force to the displacement in an SHM situation. So you get a physical situation, you find force is proportional to x. That proportionality, what appears on the left side of x, is called k. And if this force is being acted upon by a mass m, you can straight away get the time period by putting this equation, t is equal to root over m by k, where k is the force constant. What is the other important term we have seen in this equation? C. C is the maximum displacement or x max. What is x max? It is the maximum displacement inside the SHM that the particle or the body executes. So this x max is often called the amplitude of motion, and x mean is the negative amplitude. That means the body moves between the positive extreme and the negative extreme, which is a and minus a. So from the general equation of m d square x by dt square plus kx, we are able to derive the displacement function, and from that we straight away get two important properties of SHM, that is the time period of motion and the amplitude of the displacement, amplitude of SHM, that is the maximum and displacement possible under this force F, mass m and force constant k. Now we will go on to a little bit more detail about the individual characteristics of displacement, velocity and acceleration. Please remember that I had used the equation c sin pt, and I told you t is equal to 2 pi by p, because this function repeats after an interval of 2 pi by p, and in case of physical motion it is nothing but the time period that is after such and such time the motion repeats itself. You can verify yourself that if you take a particular time period t, x is equal to c sine pt, and you take at x at t plus 2 pi by p, then you have to put here c sine, instead of t you put this value, so p into t plus 2 pi by p, this is equal to c sine pt plus 2 pi, and you know any sine function which is pt and you add 2 pi to it, it is the same. Sine theta is same as sine 2 pi plus theta because it just completes a full revolution. So you can see that after 2 pi by p time the displacement repeats itself. So this term is appropriately called the time period of motion in case of SHM. Well, you know that not just sine function, the cos function will also do. So for example, xt is equal to c cos pt will also do. Look at it. I am taking the term p, whereas the common term is omega, so that you do not get confused between omega, which we had studied in the circular motion, as the angular velocity. In fact, p is called the angular frequency. We have seen that t is equal to 2 pi by p, which is periodicity. And while t is the periodicity, 1 by t is the frequency. This p term itself is called the angular frequency of SHM. P is equal to angular frequency of SHM. So xt is equal to c cos pt will also fit the bill in case of this. Not just this, sin pt or cos pt, a combination of both also will fit the bill. So we get solution like this: x is equal to c sin pt, also xt is equal to c cos pt, xt is equal to c1 sin pt plus c2 cos pt, also will be the simple harmonic motion having angular frequency p and time periodicity 2 pi by p. All of them have the same periodicity or the time period. Then interestingly you will find that we will study this in greater detail: sin pt plus phi, where phi is called the phase angle. This will also satisfy the solution to this second order differential equation: x is equal to c sin pt plus phi, and conversely x is equal to c cos pt plus phi will also satisfy the equation. We'll study in detail what exactly is this phi and when we come to plotting the graph of these functions. Now we want to derive the velocity and acceleration from this solution that we have got. We found x is equal to c sin pt. We take the sine function and derive it. Now I have come to a phase when we can disband the c and p and replace them with a more familiar sign a and omega. C is replaced with a, where a is amplitude, and p is replaced with omega, which is the angular frequency of SHM. So can we now move to this x is equal to a sin omega t. Now if x is equal to a sin omega t, where a is the amplitude, omega is equal to angular frequency, and omega is equal to angular frequency. We want to find out what is velocity at time t. Now velocity is equal to dx by dt, which is equal to d by dt of a sin omega t is equal to omega a cos omega t. What is acceleration? dv by dt, which is equal to d by dt of omega a cos omega t minus omega square a sin omega t. Now we can see that a sin omega t is also x, so we can tell minus omega square x. Please see that acceleration is also proportional to displacement but opposite to displacement. These are the three important equations or important results of SHM. X is equal to a sin omega t, v is equal to omega a cos omega t, a is equal to minus omega square a sin omega t is equal to minus omega square x. So we write here the final equation f is equal to minus kx. We can now write ma is equal to minus omega square x. And you can see that this term omega square is an important term here, because this is the term which defines the relation between acceleration and displacement.